Hi, this is the Intelligent Bike Safety System project. In this video, we're going to go over a little bit about what our project is, some practical uses for it, and we're going to give you a brief demonstration. Here's our team. First is Nitin, who worked on the crash detection subsystem. Next is Yash. He worked on the GPS and communication subsystem. Ariban worked on the vehicle detection subsystem, and Andrew worked on the hardware.
Quickly going over our project description. The Intelligent Bike Safety System aims to protect bikers from vehicles on the road with 3 different safety mechanisms, each utilized by one subsystem. First, the vehicle detection subsystem uses a LiDAR in combination with the stepper motor and haptic motor to provide eye-free alerts to users as cars approach them from behind. Next, the crash detection subsystem uses an IMU along with a high-G accelerometer to detect crashes should an incident occur. Finally, we use GPS and communication subsystem, which uses GPS to send a precise location of where a crash might have occurred, along with BLE and Wi-Fi, using a mobile application to relay the information to emergency contacts and eventually emergency services. Finally, all of this is tied together with the PCB on our hardware.
There are many different uses of our Intelligent Bike Safety System. The primary use is for cyclists using the roads to travel. Again, we're trying to detect big vehicles that are approaching them from behind so they can be alert. Now, this can also help cyclists who have hearing or vision disabilities. Let's say they're not able to hear cars approaching them from behind, or maybe they can't see them as well. The haptic motors on the handlebars will alert them so they're able to feel whenever a car is approaching, and their hearing and visual disabilities won't affect them. Another use could be a solo cyclist isolated in low traffic areas. Now, this is mainly related to our communications and crash detection subsystem, which if the cyclist does end up in an accident, emergency authorities and an emergency contact will be alerted, because in these low traffic areas, there might not be much help around. Another future use could be cyclists traveling in groups. If we optimize a bike safety system to detect bikers instead of vehicles, if bikers are traveling in groups, they'll always know if a biker is passing them from the right or left, and so there won't be any issues with that. The final use case could be cyclists using pedestrian or high traffic paths. Again, if people are running or there's a lot of bikers and people going around them, it's always good to be alert, and the haptic motors on the handlebars alerting them of who is passing and who's coming behind them will always help them out and reduce accidents.
Now we'll show our system in action.
Welcome to our demo of the crash detection subsystem as well as the GPS and communication subsystem. We're going to be syncing live to our Bluetooth app as we hit connect here and begin searching for our BLE device. And then we have a GPS fix on the device and our IMUs are active and monitoring, so we can begin moving, just simulating a normal bike ride. We'll be moving at walking pace, and once the app is connected, we'll be able to see our live data that's streaming at 3 miles an hour. And here I can quickly just simulate a crash that the user might get into, and you should see the crash update on our device. Now we can wait for the countdown to expire, and we'll have a emergency notification automatically sent via the SendGrid API and emails delivering a notification to our emergency contacts. Now we'll show a live demo of our system in detail. As you saw previously, we had a car passing by, and now as we zoom in, we can see even more specific detail about the car, including the profile of the car. As we move around to the front, you'll see the hood of the car, and the entire system has been clustered, and so you'll see a color light up any of the points that have been detected as candidates for a car. And here you can see the front right portion of the car with the haptic feedback as shown before. Thank you for watching our demo and presentation of our Intelligent Bike Safety System.